Okay, so here we are, and let's resume from the previous section. It's the fourth block out of four, so this is the last 1 hour and a half that separates us from the end of the workshop. And I'm pretty sure that at this point, the time zone is definitely a bit tough for our Asian friends. It's luckily everything recorded, so I hope they will not miss much. We focus a bit only on the GANs here, on the generative adversarial networks, and we do some concluding reminders, some concluding remarks at large, depending on how much time it will be left to us. So the idea now, indeed, is to cover something slightly different and explain the concept of these, because this is a generative model, not a discriminative model in the neural network scenario. And to have some examples of what the GANs are, probably it makes a lot of sense to check together some of the generated images that can come out of these techniques in terms of cats, human faces, and even apartments. So the list of sites that I've been giving you here, some of you might know this already, are basically all collecting fake kind of images, just generated images, not real ones, okay? So this is a cat from thiscatdoesnotexist.com, actually quite realistic. And this is also a nice cat from the same site. And this is a third one. Of course, at first glance, it's quite impossible to see that these are not real pictures of real cats. So there was nobody at a camera taking this exact picture of this exact cat. This never happened. So these are just generated images of cats being using a technology that is able indeed to produce images that are resembling some set of originals somehow, okay? Another cat here where you notice something about the little legs that is a bit weird, but actually the face is fine, right? Okay, this is a person. Actually, this is not a person. This seems a person, but this is a person that doesn't exist. You might actually notice something more in persons maybe than in cats. So you see basically in the glasses, there is something weird up there. If you go to some of the details of the face, there are some circles, some weirds here that probably are not okay. So you can, but actually at first glance, it looks like a picture of a person, right? Nothing wrong with that. Or of a young guy here. The face is okay. The surroundings, not really. There is something monster-like here, not easy to understand, but actually the face is fine. The face is what is this technique is actually trained against. So of course it's very good to produce images of faces, but not about all the possible surroundings. So that's why they fail otherwise. We have some quirk for this guy here, just below the mouth. Also in the teeth, there is something wrong. Actually, there is something horribly wrong, but actually the face is meaningful, okay? Also for this lady, probably you find something, maybe the shape of the internal of the eyes or the teeth, there's something that is not so regular, okay? Or this guy here, definitely the teeth are a bit alien-like, there's something weird, also the eyes, but actually not completely unconvincing. The background at the same time is not okay. So what happens behind all these pictures, good or bad, that you like it or not? What is behind this picture? Why they can do it so easily? Same for apartments. Why is it possible to make plots of apartments in a website that looks like a B&B kind of site, but actually, what if I tell you that these apartments don't exist? There is no such room with those furniture, with those kind of decorations and things like this one doesn't exist. Also, the text of the announcement was basically generated. This doesn't exist at all. The same for this one. They are realistic. There are some weird things here and there if you check, but they sort of look realistic, right? So wouldn't you click to rent one of these? Okay. So this is the idea. So we need, first of all, to develop the intuition about what a GAN is and how it can be designed. And then maybe we check the code actually and implement some, okay? So one of the best intuitions that I can think of about the generative adversarial network is an analogy with a counterfeiter. So a thief that is trying to make fake banknotes and doesn't want to go to prison. So this is my analogy. So you have You have a counterfeiter there that is trying to make money in a way that the policemen will not find the money to be fake. They will not find out. And so if it goes to prison, it's bad. Then maybe it goes out of prison and continues to try the thing. This is the idea. So the first kind of banknote that it might deliver to the policeman to pretend they are real money could be squared red piece of paper. This, of course, look like no known piece of banknote, and so the policeman, of course, sends him to prison immediately. Then it comes out and tries again and again and again, and he changes something. For example, he changes the shape and the color, so it becomes a rectangular thing of blue color. Okay, so the policeman, of course, got it. It's not a real banknote. Go to prison, and it goes to prison. Okay, so the analogy is clear, right? So he's trying to fake the policeman. It's not so easy, but actually if you do a rectangular shape, he knows that basically is not correct. The policeman tends to wait a bit more to say that's not correct, because most banknotes are rectangular in shape. And so probably he keeps the shape. It only changes the content, maybe changes the color. What about trying the green? And maybe tries the green, and maybe tries something on it, and maybe tries the palace or something like this. The more it does it, sometimes the more the police tends to take more time to say it's fake, and maybe sometimes says a doubt. Okay, maybe sometimes across the possible images on green background, he tries some face, and some of these faces or look alike, like a face actually, could be very similar to a US president or things like this. So at the end, it might end up that it basically produces something that is very similar to a dollar. Okay, the policeman is completely taken into a trap, and of course he doesn't go to prison, and so he can be rich, because at this point he can print all the money he wants. Okay, so this is basically the analogy. The counterfeiter in this case is a neural network that is called the generator. The policeman is a neural network that is called the discriminator. So the generator is taking stuff from a random noise and producing stuff that the discriminator, that knows something about what the generator gives to him, but also real data, so real banknote, he needs to understand if the data is true or not. So if the image is real or fake. And then, of course, this is fed back to the generator, and the cycle continues. Okay, this is basically the idea. So GAN somehow are slightly intimidating because they look like reinforcement learning in a way. So a completely different guy with respect to other stuff. They are closely connected in a way to our attempt to understand the basic mechanisms of the way we think and learn somehow. So, and reproduce these. So think about the way we learn. Actually, we learn in that way. So I learn a skill, then I'm evaluated, I get feedback on what I miss, and probably I learn again with a focus on what I was missing, and try to unlearn things that I missed, that I learned that actually were not correct and were not contributing positively toward the skill I wanted to achieve. Okay, so and you continue this cycle until you master that a given skill. This is a way you learn at school somehow, no? And this is roughly how GANs work. So you have the teacher and you are the generator somehow, if you think of it. So the GANs came out in 2014 as an unsupervised deep learning technique proposed by Ian Goodfellow and others. And the same Ian, of course, of the famous deep learning book, by the way. So this is a very interesting paper and book to read. The idea is quite groundbreaking, honestly. So the idea of adversarial training, so having neural network that competes one against the other to reach a goal, is widely considered one of the most interesting ideas in the field over the past years. So Ian LeCun himself, the one of the NIST data set that we discussed earlier today, a few years ago said that it's indeed the most interesting idea in the last 10 years in machine learning. Then, of course, there is a wide debate. And also the GANs were actually jumping to the floor a few years ago, a couple of years ago mostly, and then now are a bit stabilizing a bit for various reasons. But still, it's a very, very interesting idea to consider, okay? The problem is that with the GAN, it's quite tough to do the training for professional level networks. So the idea is very exciting, but actually to make it work is not as simple as other stuff, okay? So it's relatively quite complicated. Definitely the idea of making neural network compete against each other is absolutely genius-like. So I really like the idea, okay? So What is inside again? You have a generator and a discriminator. The generator fights against an adversarial network, okay? That is the discriminator. The generator itself is a network, but does its task, but needs to fight with an adversarial one that is the discriminator, okay? Both these networks are relatively simple in the sense they are multi-layer perceptron. The generator has a simple objectives. It needs to generate data that one cannot distinguish from the training data. The idea to do so is basically to get a feedback. So it can do so and continue by getting feedback from the discriminator. So the checkpoint is indeed to demonstrate you are able to trick the discriminator. And this is your objective, okay? The discriminator instead has the objective to get something from the generator and say if that is real or fake, okay? How does it do it? It gets two flows of information. The first comes from the training dataset, and the other one is the modeled dataset that the generator generates, and the feedback comes back to the beginning. Okay, so let's discuss this for a second as a kind of model. This is not a discriminative model. Discriminative model are those we discussed this morning somehow. So decision trees, support vector machines, and things like this. What they model is a conditional probability. Okay, so the probability of a given label y given the x's, the features that I have for my training set. In doing this, you don't make assumption basically on the input distribution. So you learn, for example, if you have a classifier in the discriminative model whatsoever, you learn the decision boundary between classes. And given the data you have, this is model-based learning, remember, you predict the class to which a particular data entry belongs, okay? So you have some information, some set of features that are very informative, and then you build a model that is discriminative. You are on this side, class 1, you are on the other side, class B, to keep it simple, okay? So this definitely has characteristics. They are relatively rigid, very easy to train, etc. Some cons could be that, for example, on outliers, of course, you cannot be perfect. The confusion matrix always has some zeros apart from the diagonal. You cannot do much about that. But actually, you can be very effective with the discriminative model. On the other side of the river, you have the generative models instead, which are completely different objects. They learn the joint probability of the input data X and output data Y, and they make prediction based on conditional probability. So given an output label, they reconstruct the inputs, okay? So they sort of learn the distribution of the single classes that you have. So in this sense, they can help to reconstruct the data you get in inputs, okay? So these instead perform quite well on outliers. They are able to sort of reproduce them, okay? And they have a special ability in being able to generate new data points that are very similar to your training set. So this is the way in which I mean when I say that they are generative, okay? So coming back to the flow of a generative adversarial network. So you see the generator is there. You're trying to counterfeit money, okay? So you have some random noise. You start from that are created from the training data, just like your image. And then you try to mimic the input as close as possible, and you hope basically that the discriminator gets fooled. Regardless if it is fooled or not, of course, the discriminator at the same time is doing something and is studying real data from the training dataset and fake data from the generator. He needs to identify which is real, which is fake. And actually, when it does it, of course, it has a feedback, which is a classification error. And this feedback is fed back indeed to both the generator and the discriminator so that they can learn and continue the process. They continue to compete, but the objectives are different, okay? So since it's not a single network, you cannot train it like a single network. It's done of two networks. And the objectives, as I said, are different. So the training must be different. And the training iteration is complicated because there are two phases in every round, okay? Phase 1, you train the discriminator, the policeman. You take real images sampled from your training dataset, and you put together an equal number of fake images by the generator. You set the label, like 0 for fake, 1 for real, and you train the discriminator based on this label batch for one step. You use as a cost function, the binary, of course, is 0, 1. So a binary cross entropy is just fine as a loss function, and you continue until the end. Be careful that you are training the discriminator. So the backpropagation algorithm in this case is taking care of the weights only of the discriminator, not of the generator. This is phase 1. Phase 2, you train the generator. You use the generator to produce another batch of fake images, okay, to other fake images. Then you use it again, the policeman, to tell if these images are fake or real. And this time you don't add real images in the batch. Right? All the labels are set to 1, so that the generators produce images that the discriminator will eventually perhaps believe to be real, but he might be wrong. Okay. When you do this and you train the generator, make sure that the weights of the discriminator are frozen, so you don't move them, you don't change them. So in this case, the backpropagation only affects the weights of the G, of the generation. This is the phase 2. So in phase 1, you do focus on the discriminator. In phase 2, you do focus on the generator. Altogether, this is one cycle of the training procedure. Okay. So as you have noticed, in the weights training, the discriminator network is seeing both images from the real set, the real ones, and images that are created by the generator. That's for sure. But note one thing, the generator actually never saw any real image. Okay, actually needs to produce something that is convincing. So something fake that can convince the discriminator. Okay. So if you want to see how GAN is being applied, actually GAN can be applied in so many areas. It can be used to generate high resolution images from low resolution images, to put color on pictures, to generate a text that describes a picture based on the images that you have in the picture. You can do image editing, like you have a photo bomber behind yourself in a holiday photo of a few years ago, since we are not traveling now. Well, you can remove the photo bomber and put a realistic background. You can turn a little sketch on paper into a photorealistic image. You can apply different styles to images. Okay, you can predict what's next frame in a video, of course, because videos are sequences of images. You can take a data set and augment it by generating similar images, for example, similar data there, similar distributions. You can generate new types of data. You can generate text, you can generate audio, anytime series. You can also use it to identify the weaknesses in other models and try to increase their strength. Okay, of course, there are bad applications in a sense, sort of not so useful, and also eventually even dangerous, like all the deep fakes. But actually, they are interesting technically wise, nevertheless. Okay, so it's time now that we try to do something with the GAN. And if you want to move to the notebook that I opened before to bypass my network troubles in doing large use of the bandwidth in my office today, this is basically, let me scroll up to the top. This is basically the notebook that we might be using today. Okay, there is some people that should probably mute if there are no questions. Okay, and so this is basically the notebook, how it looks like at the beginning. So it loading data, something normal. We are using NIST again, okay? So we are importing plenty of stuff to do the GAN implementation. We are importing NIST, download this stuff, and then creating some function that will be described as usual in the slides, okay? So you have it there. Take the one that has GAN in the name, of course, and let's come back to the slides themselves. Okay. So the idea of this little exercise is quite simple. I would like basically to spend some time with you to explain how we can implement a GAN to attack the NIST problem by trying to reproduce the NIST images. Okay, like if we would like to use this technology to augment the amount of data that we have in the NIST dataset itself. Okay, using a GAN. Okay. So it's quite educational, I think, because we are still using the same simple images, okay? And actually it allows also to compare in terms of training time, complexity of the code, different portions of the tools that we use in Keras and things like this with the other approaches that we did. So I would like to see a GAN that identifies the latent feature representation of those images and explore basically how good a generation can become in generating digits like the mnist ones that look real, okay? And if they can win in a comparison against the discriminator power, okay? So the implementation is relatively simple. We are putting these images into the game, okay, and we are trying to generate some of these. They will look like a white noise at the beginning, then iteration after iteration they will become much better. The real data, we have them, and the discriminator should be able to tell us which is true and which is fake. Okay, so the GAN implementation is done in this function, which is called the create generator, okay? So this generator, if you see, is using the Keras sequential API here. So I'm doing add, add, add. I'm using sequential at the top, of course, okay? And then a series of additions. And this creates a multi-layer perceptron with basically a sequence of very simple dense layer that are activated not by the ReLU, the rectified linear unit as of before, but by a modified version of that that seems to be slightly more efficient for vanishing gradients and other effects, which is called the leaky ReLU, okay? Never mind, it's an activation function. And you have also the hyperbolic tangent, by the way, in the final dense layer. So what comes out of this, as you can see, is that, this is important to note, the final layer is not spitting out two things like yes and no. And it's not even spitting out 10 things like identifying 0, 1, 2, 3, as we did before the break. It's spitting out 784 objects. Of course, these are the pixels that form the generated image, okay? Good. The generator is something like this if you check it with the typical plotting features that Keras provides to you, okay? And you see that the trainable parameters in the generator of a total of 1.5 billion are basically all of these. So quite some features, right? Okay. The discriminator instead is not so complicated, but there are of course some differences. First of all, as an input, the dimension it gets is indeed 784. Makes a lot of sense, okay? This is the same for real data and for the generated images by the generator. Then after that, you have some leaky ReLU. You have also the dropout, so some connection basically are not used. Let's not focus too much on this detail and continue through dense layer up to the end. You have a sigmoid activation function, and for the model as a loss function, you have for the classification indeed a binary cross entropy and Adam as the optimizer for the training. This is the discriminator. Again, a multi-layer perceptron. As you see, they are different. There is a function, def, for the generator, and there is another function for the discriminator. There is no functional API, no outcome from a network layer is coming as input to a network layer of the other one. So they are completely different network. One is the gen, one is the dis, and they are created by different functions, by the way, okay? So this is it. And actually this one, if you compare it, again, it has of the order of 1.5 million parameters. All of these are trainable. Okay, and now you create a GAN. There is a third function in the code that creates the GAN by combining the other two networks. So you see, create GAN takes a discriminator and the generator as input. You select something very clearly in the second line here, discriminator trainable false. When we train indeed the generator, we need to freeze the discriminator. You will see it in a second. What it comes as input to the GAN is a shape of 100, okay? So 100 units gets inputted to the generator. And then, of course, the generator output is fed to the discriminator, okay? This is how you create the global GAN. Adam as an optimizer is binary cross entropy as a loss function. So this is how it looks like. And if you notice, the total number of parameters by this combination of the two is 3 million, which makes sense, but only a part of the parameters are trainable. There are 1.5 million of parameters out of this that are not trainable, which makes a lot of sense, as we said. We have frozen these. So the total number of parameters is the sum of the two, but only those of the gen are trainable parameters, okay? Good. If you put things together, basically a gen plus this that forms a GAN doesn't stay in one slide. So you start to increase basically the complexity at the level where one slide doesn't tell you the full story. So I need to basically divide it into 3 pieces. The input is flowing from here, goes downwards, and goes downwards, and then goes downwards, downwards, and you get to the output there. Okay. So how do you do the training? In this case, you need to be really careful about the number of epochs because it can be expensive. So try to do in the notebook with just 1 epoch to start, okay? The training is done by loading the data, of course. I don't go into detail of how most of these easy things are done. Then you create the generator by calling the function generator, create generator, and create discriminator, and you have these two, and then you create the GAN by feeding it with 2 arguments that you just created, and now you have the GAN. Then there is a nice trick to use TQDM just to have in the loop something that is visible and you can monitor. So you see some useful progress bar flowing in the code if you try to do that, okay? And then, of course, you need to create some random noise inside the loop to initialize the generator. So now at the moment, this is not the entire code, of course, it's continuing in the next slide. So now we are entering in the loop across all the epochs, in this case, 1 epoch, and we are doing this for to monitor the things. And what are we doing here follows in the next slide. So first of all, you generate some random noise, which is one that gets fed to the generator to try to produce the counterfeited images, okay? Then if you continue, the gen generates indeed the fake MNIST images from the noise input that is being given, okay? The fake part is that one, okay? The real part instead is this one. This is where you get a random set of real images, okay? The third part that you have here is when you create a different batch of real and fake data. So basically, you need to concatenate these. Okay, you create batches of data that contain fake images from gen and real images from the real MNIST to confuse the discriminator, and you concatenate them and you send this to the discriminator. Then you create some target variable for real and fake images, and you start the pre-training. You see that at the beginning, when you start this pre-training on the discriminator on fake and real data, that are the X's that you have down there. You give labels to do so, which are these Y here, and you do this before starting the GAN. And in this case, you have the discriminator trainable that is set to true, okay? If you continue, you trick the noise output of the generator real data in this part, and then later you put to false the trainable here, trainability of the discriminator, and then you continue with the training of the GAN. At this point, you need to freeze the weights of the discriminator so that the GAN. Sorry, Simon, can you mute, please? Simon, can you mute, please?
没有，要那电，这电太细了，不是，它太细了，这可以通啊，那太细了。
Let me try. I'm not sure. Okay, probably. Okay, I think I managed to mute. We can continue. Sorry, I was a bit distracted. So when we train the GAN, we need to freeze. We set the weights of the discriminator. Okay, so it's an alternation. We alternate the training of the disk that was in the previous slide with the training of the chained GAN with the disk weights that are frozen, and it's in this slide. So that's why before basically you had different freezing than in this one, okay? And then every some epochs, in this case 20, you plot and save the image that you generate. So basically you can see image after image, which is the quality of the generated images, okay? And then you launch the training. In this case, be careful, don't launch it like that. The training might have quite some time. It depends on the resources you run on. In this case, it's quite heavy for 400 epochs. Don't look about this wall clock time. This is probably from a previous measurements. What I did so far on the notebook, I think it took me a couple of hours to get to the end. So you cannot do it within the workshop, but you can definitely give it a try afterwards. Okay. Okay, so let's look at the results from the notebook, which will appear. This is what happens when you have basically one epoch. So at the beginning, you start with something that looks like that, okay? So if you zoom one in, the quality of the things you have in the middle of it definitely is far from optimal, okay? You cannot really recognize anything out of that. It's quite clear you can't, okay? If you go to epoch 100, if you have some patience in your codes, in executing your code, the training in your codes, you see some numbers appear, but they appear like crazy images, more or less, okay? In this case, they are not colored images. I don't want to distract you, by the way. It's just a different color palette from the black and white one, okay? So they are not colored. Different intensity scales are here from yellow, the lighter, to dark blue, the darker, okay? But it's like black and white, okay? And what you see there is that some look like numbers. So you can pick your favorite one. Maybe this is definitely a 1 in the middle here, no? But the one here on the left, maybe I use another cursor and you can see it a bit better. If you check this one is a 1 for sure. If you move to this one, well, you could say this is a 2, but you also see that the way the curvature is done could actually be faking the 2 as an 8 or the 8 as a 2 in a variety of ways, right? So the discriminator can be cheated in thinking that this is basically not a 2 but an 8, or vice versa. This I don't know how to interpret it. Probably this is an 8, I'm pretty sure. This I'm not really sure. This looks like a 6, but who knows? This is a sort of a monster. I don't know. So you see that something is appearing. Sorry, my voice after many hours is going away. Some numbers are appearing, but they are far from being clear. But anyway, it's epoch 100. So in principle, you can continue your training if you have time and computing resources and money, which is basically the same in different unit of measurement. Epoch 400 looks like this. So if you zoom one on the right-hand side, a 3, well, that's not bad, right? So some are really okay, not perfect. Look at these ones. So these are indeed generated like mist, but they don't look like, well, that's a bad 2 perhaps, yes, but that's not really nice. This is not nice. This is also not nice, but this is just a 1. I'm sure we all agree this is not an 8, for example. I'm sure we all think this is a 4. Or go to very simple ones like this guy. This, well, that's of course a 5. I mean, you can continue and select your own and make your judgment. It's still not perfect, no? So this is a 3 or is it an 8? But actually there is a lot of progress being done across the generation process with respect to what happened in the first few epochs, okay? So this is basically the results you could expect. That's it that I had on GANs. Okay, so I don't want to push you more on that. I wanted only to show you one thing from here. If you go to, I'm not running the notebook right now, but you can, of course. But if you scroll down to the position in which, if I still have it, yes, I still have it, where I have the training for 400 epochs, you see that basically this is the kind of monitoring that you get. And you see epoch by epoch, how it's going with this bar that is flowing. And actually this takes quite some time if you check, okay? I wanted to show you how long it took because I told you a number. I want to give you a reference for that one. And 400 is here. And you see the time it took as a whole time here. So it's 2.5 hours to do this. Of course, you can change some parameters. You can probably do some of these things better than I did, but still, I would say that probably we are on track on those times, okay? So this gives you a feeling, I hope, of how you can do even generative models in a relatively easy way with Keras. All we did here, of course, can be done completely in the same way, just using other frameworks like using PyTorch or other similar machine learning frameworks. The main concepts in general is the same. And the way I try to approach these was to show you what some selected architecture of neural networks could do, okay? And as a result out of this, try to apply these techniques to a specific case in classifications or in generation or whatever that is always related to NIST, because I think this was the most interesting and easy things to give a try on if you are at the beginner level in machine learning, as we agreed that this work should have been aimed at the beginners and not at experienced people. Okay, so this is basically the idea. I don't want to push you further. We still have some time, but I'm open also to give some time to questions from you. I have some bonus material to share with you that basically is declining. It's not in the slides, it's declining towards the bias you can have in artificial intelligence systems and the ethics in artificial intelligence. It's very light and I keep it for the very end. I don't want really to spend the entire time until 5 p.m. because it's late night also in Taiwan and it's not really kind to do most of the content there. So I try to squeeze most of it at the beginning, but I'm open to take any question or doubts or whatever right now, or to go through the bonus material before we close the workshop and we adjourn. So let me know if you want to say something,
Daniele?
to ask something. Yes, please.
Just maybe this is not a good time to ask. Just wondering, I mean, these are sort of typical machine learning techniques and stuff. So can you give a few examples of the use of this machine learning in high energy physics?
Oh, yes. Well,
don't have to just you know.
No, sure,
sort
sure.
of. Yeah.
So specifically in energy physics, machine learning is extremely pervasive. And there is probably a change of gear over the last few years, because at the beginning in energy physics, most of the things that happened was to use basic non-neural network algorithms and no deep learning, basically. But something like decision trees and boosted decision trees are definitely a good way in multivariate analysis to perform most of the analysis. And this is contributing a lot. Actually, it has already contributed to the discovery of the Higgs boson, for example, in the resolution of the electromagnetic calorimeter in the CMS experiment, as well as in using TMVA techniques in Atlas and similar things. So this is an approach that has been used for quite a long time. So the advantage already at those times, quite some years ago, was basically to save time. So you can potentially use these techniques to get to the discovery, for example, of the Higgs boson in a time that is, given the sensitivity of the experiment and the actual data that was being collected at the time, that could have been expected 1.5 years or 2 years later than it actually happened. So you can make the best out of the statistics you collected, okay, which is already a big advantage. And this was used for so long. Then one thing that came afterwards, at some point, is that the idea of using some physics driven high-level knowledge and do some feature engineering by hand sort of evolved, at least in some sectors. For example, jet physics evolved slightly towards getting low level. So trying to use all the features that you have in the data and use this feature as input to more complicated neural networks. So we started to use an energy physics neural network a bit later somehow. And now neural networks are used in so many applications. There are recurrent neural networks, for example, that are used by basically treating the evolution of an event like a sequence of information somehow, so that like you process a sentence or things like this. And There are convolutional neural networks that are used a lot, especially in engine physics, in all the experiments that are based on images. Neutrino physics, where you need to disentangle a neutrino oscillations event from a cosmic background event, is used a lot, like NOVA, microboon, and experiments like this. You can do jet classification or even event in general classification also at the Large Hadron Collider with these techniques, with convolutional neural network, etc. Autoencoders are interesting because they are used they are being explored, at least in the use to discover new physics. So the idea that you can extract the latent representation of the data that you have is amazing, because you can basically see which is the latent representation, if you want, of the standard model. And if there is some deviation from the standard model, probably that's a symptom of an interesting event that should be sort of analyzed with a bit more care by others at a later stage. So basically, all the possible architecture are being explored in one way or another, even some reinforcement learning, for example, to make sure that the automatic operations done by the shifters on some systems actually could be automatized in a way and could be done by a sort of a robot or things like this. So there are a lot of exploration, and there is definitely a sort of a change of speed in the way young generation in high energy physics are approaching this. In a sense that they tend to be a bit more open to other disciplines, a bit more interdisciplinary by construction. So interdiscipline for me means not two people from different backgrounds working together, but more the fact that the sum of the two different knowledges is more than two people. So you create some additional knowledge somehow. And definitely younger generation are more open to that. So there is a complete match of computer science, data science, and a physicist towards common objectives that work together from different perspectives. And a lot of things, of course, are coming thanks to the young generation. So this is really interesting, because all the techniques here are really attractive for those that have some software and programming and computing skills. Okay. Apart from this, one major problem in pushing the discipline in ING physics deeper than that is potentially twofold. The idea that the disciplines are not done by the young people, unfortunately, and the old-fashioned statisticians, mathematicians, computer scientists, and high-energy particle physics tend to speak different languages. So they need to understand each other. And that's not always possible. Also, the jargon is different. And it's very difficult, for example, for high-energy physics to formulate a problem in a way that is interesting to a computer scientist that probably is mostly interested in something else. And so it's difficult to put the people together. That's why I'm investing a lot of hope in the new generation, not really mine. The other problem that we have is the fact that high energy physics as a habit, that might be a good thing because it's a clever community, but might be also a limiting factor that is going to be addressed and solved nowadays, I think, which is the fact that we tend to develop solutions at home ourselves. So we develop the way we do analysis, we develop our tools, we develop our analysis systems, we develop our formats, and we do things like this. This might become also a limit, because a lot of things in machine learning is happening in the non-HEP world, so outside of high energy physics. And I definitely think that the value can come in being able to bridge this kind of expertise and knowledge into our community. And if there is a limiting factor of the fact that we are not using the same solution that other people in the world actually use to do machine learning and deep learning, then we have, of course, a problem. So the more we can use Keras like everybody else, PyTorch like everybody else, we can make also our problems known by the community there, and they can come and help us to develop solutions that are better for our case. This, I think, is the process of, I mean, putting different knowledges together towards a common scientific goal somehow. So I hope it gives you a feeling of how I feel about machine learning in high energy physics. But nevertheless, there is also in ISGC the plenary talk that I'm giving on Thursday, which I still need to finish to prepare. And there will be some examples there. So probably you will have some more there. Okay.
Wonderful. Thank you. Maybe some other people will ask questions. I got another one, which is the use of unsupervised learning. Do we use that in high energy physics?
Yes, you can use definitely this in various contexts, definitely for dimensionality reduction. If you do principal components analysis to simplify things also before doing something else, you do so. Most of the unsupervised can be used, for example, in classifying events. So the more you have information that are not clear and you don't have the labels, you can group events by characteristics and then maybe make sure that that is a useful classification for the subsequent step, etc. In general, it's definitely dominated by supervised learning. So the more you can use Monte Carlo for something, the more you have the truth about what you have. So you can train things on Monte Carlo. Your training set basically are Monte Carlo samples. That, of course, gives you by definition a label. So it's mostly supervised, but you can also exploit definitely some unsupervised techniques. Yes.
Thank you.
Okay, thanks to you. If there are other questions, I'm glad to take them. You mentioned, oh, let me check on the chat window. There are a couple of things. No, this guy is leaving, but this is a question here. You mentioned an interesting book earlier. Are there resources you would recommend to follow up on the workshop? Oh, thanks for the compliments. No, so yes, of course. Well, there are many. Probably the best would be, since I have a mailing list of you attending the workshop, I can type some suggestions there and send a mail. Probably that works better. My suggestion definitely is potentially twofold. There are excellent books, threefold. There are excellent books about the theory, and you should definitely read and study these. There are excellent books that don't neglect the theory, but simply can try to do machine and deep learning without using too much of the theory, in the sense that they give it for granted, but actually they develop some intuition about the theory and just apply, okay? And I think there are very different books, like the Ian Goodfellow Deep Learning is of the first kind. The one that I credited also on the slides by being inspired by taking some of the examples and discussions by Aurélien Géron is definitely of the second kind. He did an amazing job over his PhD, and actually the book, the first version, the second is even better. The first version of the book, just for you to know, are basically the notes for his PhD, he told me once. So it's that's impressive. It's an impressive amount of work done at the PhD level. It is one of the best book for putting your hands into the game immediately. And I think you should have the two, because the second kind of books allows you to get to your result quite quickly and you don't get frustrated. And if you do it in the right way, you don't lose the desire to learn the theory better, okay? While if you read only the first kind of books, you never try to apply things. And that's in machine learning is a mistake to me. So you really should be, in my view, at least, that's the personal view, you should really take the approach of the applied machine learning kind of person. So where you study what you need to study, if you don't know it already, of course, you continue to study your entire life, but you apply stuff. You try to play with stuff. You try to see if that works. If that doesn't work, come back to the theory, whatever, but do that, okay? Then there is the third suggestion, which is completely the opposite. Don't use books. Of course, you have internet, but don't Google stuff, because that's difficult. There are a couple of things that you should do. Find experts around and see what they do. If they have a blog post, read everything. If they post links or papers on Twitter, follow them and read what they post. Everything, every single bit. If they do something like open a site with a suggestion for newcomers, and you are a newcomer in machine learning and you like the person because of his reputation or her reputation, do what he suggests, okay? There are many things. And there are Kaggle challenges. They give you data sets and they allow you basically to be checked. You don't need to apply to a Kaggle challenge to win money or to become famous and write a book. You need to do that for learning. And that's definitely a very good learning ground for newcomers, okay? And not only for newcomers, by the way. And these kind of things definitely help a lot. Then there are online courses too. Be careful about online courses, because you might spend plenty time more than checking a blog post. But at the same time, of course, some of these are absolutely amazing, starting from the very famous one from Andrew and G in Coursera on the basics of machine learning, through the crash course in machine learning that Google provides, and many others by Slack and other university. MIT does it, and different platforms. You can find quite many things. You should probably select some of these. So the general ones, you really have an amazing teacher to transmit you everything. If the teacher is, well, good but not amazing, probably select something specific, because as I said, being a machine learning expert is almost impossible. Being a computer vision expert is very difficult, but it can be. Being a natural language processing expert can actually be possible, and probably this guy produces a course you might be interested to follow. So you see, theory of books about the theory, some hands-on books that actually give you some code, etc. All the social media, blog posts, or whatever, and online courses, YouTube videos, whatever you can find. There are very good people giving for free material for courses that are of very, very high level content. So they are good people, indeed good people. And especially in these periods, we'll find something amazing, because we are not in lockdown since 1 month. We are in this bad situation since 1 year and something. And the people who could have the luxury to invest in this increase the quality of the online content of their courses a lot. Okay, this was done a lot, especially in the Facebook AI surroundings. You should follow that. And so these are basically my suggestion. There might be many more, but this is what came first to my mind. That's it. Okay. Okay, so I will try to collect also some links and suggestions to materials, and I have something relatively old that I should probably be refreshing, but it will be my pleasure to share that with you. Probably one thing I can do, which is probably even the best for you to contribute, as some of you might know or have tried already some resources that I might not know, since there are so many. I can open a Google Doc that is editable by everybody, where I put some material and I give you the link on the mailing list. So if you have something additional, you can just put it there. So you work as a team, and everything you have can also be useful to others. And it's not only me talking to all of you alone. Okay, let's do that. I will do it within the week, or within this or next week. Give me some time. This week is heavy, and then you will have the material. Okay. Okay, so it's 4:20. So if you agree, since we have until 5, you are completely free to drop if you have something else. I promise to be doing something until roughly 5, so I don't want to disappear 40 minutes in advance. So if you don't fully disagree with that, there is some material that probably could be interesting as a discussion. Don't take it with like anything really, really crucial. It's more a sort of a final chat in this workshop to complement some of the code and slides that you saw, with some generic discussion about AI. And it has to do basically with the risks that are connected to AI in general. We approach basically machine learning, but AI is part of a big discussion, probably the discussion of our times nowadays. I'm not talking about AI in terms of strong AI, so the general AI, so somebody that does all the tasks that humans do, but I'm also talking about the risk of the small, weak AI, so the one that basically is indeed the one we discussed, so something very specific to perform a task. The reason for this to have become sort of a discussion in society nowadays is because we feel the problem not to be a problem, while actually is a problem, and it's actually a very big problem. So it's one of the very few fields that has ethical implications, in which you need to tell people that there are ethical implications about, I don't know, the developing weapons. It's clear to everybody there must be security needs for weapons, but also war needs for weapons. And so you need to explain, you don't need to explain there is some ethics behind it, but actually for AI you need, because people think, oh, it's only good, it's only good, or somebody say it's only bad and for everything. It's not so clear, of course. There is something in the middle. So there are some risks, not only opportunities connected to AI. And the best thing, of course, as usual, is to increase the knowledge. So if you know more also about the risks, of course, you can mitigate or even cancel them. Okay. So the idea of the risk behind the AI can be thought about this. This is probably very emotional kind of approach to the risk of AI. If I show you this image, you are for sure agreeing with me that this is a catastrophic scenario. Unfortunately, this is not dystopian because this is happening nowadays in our world. Okay, so the fact that this is bad and extremely sad and we should find a solution is clear to everybody, right? But if I show you another picture like this one, this is also a movie, right? So you know it's quite old nowadays, but it tells the story of humans that are unable to basically work on their future because they are under the control of machines. It's definitely a dystopian scenario, something you don't want to get into. Do you have the feeling by the image of that movie that this is something bad? People is well dressed, they look cool, both men and women, right? So this seems to be okay, no? And if you check this, you know which movie that is, and or series of movie, I should say, and you have the feeling indeed there is something wrong with that. Of course, it's a dystopian scenario, the one that is depicted in Terminator, the movie. But do you think it's wrong? Actually, well, yes, if you think of it, yes. But you see the image of the robot, that is, of course, an artificial intelligence driven kind of robot. Well, it's cool, it's powerful. Everything you think about it is positive, it's not negative, right? And if you don't like the testosterone kind of things, of course, you have also female machines, and that's exactly the same. All the positive things you see in the gender are somehow also translated into your image of the machine having that specific gender, right? Which means everywhere you look around AI in that sense, it's always positive. It looks like positive, but you don't understand the problem then, because it's more complicated than that, okay? So AI and society are not in a relation that is so simple to say that AI will just make good for society. Of course, the fact that AI systems and products are reaching our shelves and we can buy these and we can unlock our phone by just putting our face in front of it and things like this, of course, means that we need to be more careful, not less, because it's reaching society at large in many aspects of our society. And so there are a lot of societal issues that are related to the proper use of, in general, AI systems that cannot be ignored anymore. And you need to be aware about this. And if you work on these and you design learning model, you need to be working on that not as a programmer, but as a sort of a mixture of a programmer, an ethical person, a philosophy-aware person, a history-aware person, and things like this. So really from a human-centered perspective. This means that you need to incorporate all the requirements from the humans. So you need, the system you develop needs to be safe, need to be privacy compliant, need to be fair, needs to be interpretable, and things like this. And also very broad societal issues arise, like ethics in general, legislation impacts, and all things like this. So there is a variety of things that you definitely need to be aware. And be careful, because developing software nowadays, not as in the past, is done by people younger and younger in age, which means that a big contribution to AI in the next future could be given by people that are below 20 years of age or below 25, let's say below 25, okay? So this is definitely possible. If you are below 20, below 22, there is no chance they learned anything about ethics in AI in a university course, because they never got to university yet. And they might just be deploying some software and some principles in the software that are risky. They don't follow the good practice. So it's very important to address the very, very young people in this discussion, more than adding courses at university, because this has to do with people that are around high school and soon after, okay? To build our future, of course, we need to do the right choices now, not in the future, right? Okay, so we discussed some of these, and some of these things are really not new. If you talk about having some data sets with features and labels, and you do some work on this, is something that we discussed. And we discussed if the samples, for example, are representative, if the features have predictive power, if the labels are accurate. So let's see what can go really wrong about the things. So the representativeness of the sample is something you really need to be careful about. This is a typical example of the survivor bias, if you know what that is. So the idea was very simple. The historical backgrounds, I can skip it for you, but there are some names here that you can basically Google and find all the details. This is a picture of a plane with all the points, the red dots, in which basically there were holes caused by projectiles that were just hitting the wings and of course damaged the plane. So there was basically this guy, Abraham Wald, during the Second World War, that was asked basically to made these planes much stronger, okay, to make sure they didn't fall down, okay, they didn't get destroyed by bombs and things like this. So, and the data he was given was basically this data. So planes with the points of damage. And then, of course, what did he decide to do? He decided and suggested actually to reinforce all the areas that basically do not have these little red dots. So reinforce this area, reinforce the engines, reinforce here, reinforce there. People thought it was stupid. Why? I mean, you see where they are damaged, but the reason, of course, is quite obvious. The really damaged planes didn't come back. So you don't need to, these are basically the minimal damage. The others are the real damage. So this is a typical example of the representativeness of the data. These data points don't tell you anything. Is one minus these data points that tell you the full story. The same for the Brody helmet during the First World War. It was said that after its introduction that a lot of people came to the hospital with head injuries. And they say, well, of course, this is because this helmet doesn't work. No, it's not that it doesn't work, it works. In fact, the people didn't die. Reached the hospital with bad injuries, of course, but otherwise, without the helmet, they would have died. Okay, so this gives the feeling of what data representative means in the modeling. The predictive powers of the features is also quite important nowadays. All of us buy stuff on Amazon, for example, or similar. And of course, they suggest you product based on the previous things that you bought. And if you develop something that is for the market, you need to be careful about the suggestions you do, because you might do a lot of mistakes. And Amazon is not free of that. This is just a very funny tweet by a guy that says that Amazon thinks that his recent humidifier purchase was merely the inaugural move in a newfound hobby of humidifier collecting. So he bought a thing that, of course, you buy once every 5 years or 10 years. And of course, it's being suggested all possible sorts of different models of that same thing. That's not the way you build a recommender system, okay? That's a naive way to do recommendations. Are the labels accurate? Well, of course, Google also makes this mistake. I want to speak bad words about everybody now in the final part of the workshop. Also, Google does bad mistakes. So the label they put on images when you search for something might not be completely accurate. And sometimes some images are selected that doesn't make any sense with your search. For example, if you try to Google, or somebody tried to Google red dress, you get some images that are, of course, of mostly ladies with dresses that are mostly red or reddish, light or dark red. But there is also, if you zoom a bit more, something like terrible things with a lot of blood and things like this, which are not a typical red dress, I would say. This is a matter of wrong labeling, of course, okay? So in the ethics of AI that I'm trying to sort of stimulate your interest in, there are plenty of debates nowadays on privacy and surveillance, on the opacity of the systems, of safety and security, on automation and employment, on autonomous systems, bias in decision systems, the interaction between human and robots, how the behavior can be manipulated, the singularity, so thinking about artificial general intelligence and super intelligence, a lot of debates. It's very, very interesting. There are plenty of amazing books you can read on the topic that will definitely increase your enthusiasm in the topic. But in general, well, at least some of these are definitely very, very, very close to our lives today. Not talking about AGI that eventually might even never come, but actually some things are in production today. And if you don't care this, you could do a lot of damage today. So this is the concrete, pragmatic ethics side, basically, of AI, okay? So I'm selecting some of these and I'm giving basically one or a couple of examples on each just to drive your curiosity, nothing more than that. I'm not claiming to have the final words on any of these, but just to give you some stimulations for further reading, let's say. Okay, so the first is about the opacity of the system. This has to do with interpretability, explainability, and accountability of AI solutions. So let's keep it like that, quite simple and funny and relaxing, since we are at the end. So is this a husky dog or a wolf, in your view? Well, I don't have a dog, but probably that's an husky, right? It looks like so. It looks like it. Think about why you said that's an husky dog and keep it for you. Next one. Is this a husky dog or a wolf? Well, it looks like the typical wolf that I see in pictures, okay? Indeed, that's a wolf. Last time I showed this picture, somebody said that basically this one is a husky because there is a guy behind, okay? And of course, you don't have a guy behind a picture of a wolf, typically. And that's actually a very, very clever thing, because if you ask yourself what a machine would do, this is exactly the right answer, the right question to ask yourself. So if you ask a machine that if it can perform the same task as well as you did right now, what would you expect? That a machine is able to do so or not? Well, not so impressive, but actually the machine is able to do it even better than you are, but for different reasons, or for reasons very similar to the one that this guy who noted the guy in the background had when he gave these comments. Okay, this is actually a work that has been done in analyzing which are the feature importance, we discussed this today, which is the important aspects of the picture that drove the conclusion that the prediction is husky or dog. So in this binary classification case, which is the pixels, the set of pixels in the picture that contributed the most to give the answer, okay? So in this case, it was a wolf and was predicted as a wolf, okay? In the second case, it was an husky and was predicted as a husky. In the third case, it was a wolf predicted as a wolf. But there is a case here. It was a husky, but was predicted as a wolf. Look on the right-hand side picture in both of the couple of pictures, what the machine learning algorithm checked. It barely didn't look at the animal. It didn't. So it's always gray where the animal is. It looks at the surroundings. And of course, he found a pattern in the data. And the pattern was that behind the picture labeled as wolf, most of the time, there is no behind. And so if the picture have an high intensity, so they are whiter, it says, well, that's a wolf. He doesn't know what a wolf is. He doesn't know what a husky is either, but he knows how to recognize a high intensity in a pixel. And of course, he knows that when you get that, you have a correlation, and so he answers. So actually is not looking at the image, and you need to explain when a choice is done like this in a system. You cannot just rely in a system just because it works. You need to understand why it works. You need to explain it, okay? You need to interpret its decisions, and this is critical in the fight against the opacity of AI system. Don't use these because they work, but use these once you explain how they work, and use it for that, so that the choices can be made accountable. Okay. Second example, which had to do with the security and safety. If you see these two parts of a street signal while driving on the road, what do you do as a human? Well, would you stop? Well, no, probably this is part of a sign that tells me to turn on the right or not on the left, but I don't need to stop, right? There's nothing saying me to stop. Or maybe if I tell you something like this, probably you start thinking something differently, but because you are a human, you know what the red mean in a sign, and it's not a blue or a white and black and things like this. Then this also varies on the country, but you get the feeling. So if you have a stop sign like this and somebody puts stickers on it, actually the shapes can be very similar to the one that I showed, the only shape that are left visible for a human. Then, of course, if it's not a human, but is a Tesla car, now it's time that I speak bad about Tesla. If that's a Tesla car, actually, of course, it can be easily trapped into thinking that it says, turn safely on the right, while the sign actually was saying, stop, please, okay? So this has to do with safety and security in AI. So the concern is in the safe adoption of these. The algorithm can really be used differently than expected or misled, and actually violating some stationary assumptions they have probably has an impact. Okay. Another example is that you can break neural networks by adversarial attack. So this was a very famous paper in which a picture of a panda with a relatively high confidence level, but not amazing. If you add some noise, actually can be turned into an image, a more complicated one, but you don't see it visually as a human, but the machine sees something completely different, and it says this is basically a monkey at a 99% confidence level, which is, of course, an easy way to trick artificial intelligence mechanisms to do exactly the opposite or very wrong choices with respect to what they were designed to be, okay, to do, okay? So a third thing has to do with our impact in the job. This is a work that was done in the past on automation engineering, mostly, not only on machine learning, but this applies also here. So all the the work to make automatic the tasks in a given job, okay, through intelligence systems will turn out to steal our jobs. So we'll make that job disappear in favor of some machine doing the job. This is a list of jobs, and I want you to think for 1 second, which are the jobs that are most probably at risk to disappear, and those that are instead safe. Okay, look about these for a while. I give you the solution in 3 seconds. 3, 2, 1. Here is it. So the red ones are at risk. The orange are in the middle, okay? And the green one are safe. As you can see, there is a clear correlation of jobs to be at risk with a repetition of things that can be done by automatic voices, automatic actions, mechanical actions, automatic search, automatic suggestion, automatic kind of stuff, okay? Vision, like security guard, etc. On the other side of the spectrum, you have all the jobs that are related to really understanding the kind of person you have in front, like a nutritionist. It's not only a matter of body mass index to be on diet, but you need to be sure that you have in front of you a person that can stay on diet. It's not only giving the person a protocol to follow. You should understand which is the kind of diet you can sustain, okay? So a machine is not able to do that. It is able to compute the body mass index maybe, but not go further than that. And all the same applies. Psychologists, surgery at some level, even physicists, I'm glad about that, choreography, dancers, and things like this. So be careful, because the job has always transformed. We don't have the same set of jobs we had 50 years ago. The jobs will transform also not because of AI. It will transform anyway, okay? It has always happened, is happening now, and will happen in the future. And it will not happen all of a sudden. Just be prepared. A human that does basically a job today, it will not exist in 50 years, but there will be other humans who probably will do other kind of jobs. So the risk should be mitigated by a sort of another political, societal kind of actions in terms of education of people on science and technologies in the long term. But this is a big question, a big topic that I don't want to open. So this is definitely something that impacts our life, and AI should be perceived with something that helps human to improve the jobs, not something that should steal the job to the humans, okay? Another big category, the last one I want to address with you, is some example of racial bias, skin type bias, gender bias, and things like this. Unfortunately, this is a big problem nowadays. It's sort of somehow started for AI with this Twitter of a software developer, I think of New York downtown or in New Jersey, something like that, from the US anyway, who was saying bad words on Google Photos because basically one of her friends was tagged automatically by Google as a monkey, as a gorilla. And of course, that's extremely offensive, okay? And this is a big problem. And this is a problem that basically was not solved as of today. So since you cannot be accurate at the level of 99% in Google Photos, you need to be accurate given the penetration of the technology in society up to 99 point blah, blah, blah %, you cannot afford to do such a mistake. Okay, you really can't. And nowadays, that tweet was in June 2015, at least last year, when I rechecked, still Google Photos is not able to classify gorillas. Since they are not as efficient as they should, they don't classify gorillas anymore. So it disappeared. So of course, this is a symptom of a problem. You cannot really let the machine do things. These are the results, okay? And humans cannot fix this kind of problem. You've been seeing this basically from time to time everywhere. This is the face cap case. Beautifying selfies. So you upload a selfie and you ask the app to beautify it through the hotness filter, ended up in basically changing sort of some traits of the face. So the message is, if you want to beautify Barack Obama, that app will make it look a bit more like somebody who is not black. Okay, so this is definitely quite heavy. And of course, is done because the algorithm makes some choices that is explained also by the FaceApp CEO below. He apologizes, okay? It's a side effect, he says, of the underlying neural network caused by the training set bias. It's not an intended behavior. To mitigate the issue, we have renamed the effect to include any positive connotation. This is an effect, it's not beautifying. I'm not implying that if you are white, you are more beautiful, okay? So this is the only solution they found to change the name of the app. They didn't work yet at the point to make sure that if you want to beautify, you can beautify even by gender somehow, or by race, or by, so it doesn't make any sense to change the name of the filter because you cannot do anything else and blame the underlying neural network and blame the behavior to be unintended. You need to cure that effect, of course, okay? A third kind of bias, this is very famous in all the legal implication of AI. The Compass software was used basically for recidivism a few years ago, and there was a major lesson learned because there was a bias in that, quite tough also to explain, but actually was predicting some guy to do felonies in the future based on previous records, and was completely wrong. He predicted some bad stuff only for black persons and not very bad stuff for white persons, while actually the former didn't do anything afterwards and the latter actually did. So this is a bias due to the way the software worked, and due also to the a complex story about questionnaires and how questions were made and how they were filled. I won't go into these details, but you can feel the risk that you have with this kind of biases, right? Another very recent, last year, basically autumn last year, skin type bias came out when Twitter started to investigating the fact that was reported by some users that when you put a picture that is long, either long in width or in the height, like this, the picture is being cropped and only a part of the picture is shown in the preview in your tweet. Okay, the picture cropping algorithm, this is how they call it, is preferring white faces. So then people started to have a lot of fun with this. They put basically a picture that were very wide with a white person on one side and a black person on the other, and posted a tweet attaching that picture, try to see which is the picture cropped image that is being displayed in the preview. And most of the cases, actually, you saw only the left-hand side of the picture when there was the white person. And this is completely crazy if you think of it. Okay, you shouldn't do this. And Twitter actually apologized as usual. We tested for bias before shipping. We didn't find any evidence, but it's clear we got more analysis to do. I really like it. It's clear that we've got more analysis to do. Sure, it's clear. Now do it. We'll continue to share what we learned, blah, blah, blah. Okay, but it's very heavy what happened there. Okay, there are so many examples like this. So he said also that it had tested against this bias and didn't find anything. So if this was found by the users, you might ask yourself, what did you test against? Because this was relatively easy to find. And then there is also non-racial bias, but the gender bias. The gender bias, of course, is a problem in our society. We need to be very careful as human beings not to have this bias. And of course, we need also our system, our software, not to reflect our bias in a way. Okay, so this is a typical example. This is something which I think Windows fell as a company in their machine learning efforts in the past. I'm not 100% sure. Probably I should check the reference here. Anyway, what you see here is that the idea was to take pictures of people in the kitchen doing something and try to understand who is doing, the agent, woman or man, which food was cooked, which kind of heat you have, like the stove or whatever, which kind of tool you were using, and where you are in the kitchen, outside, etc. And you see basically what happens. In this case, the artificial intelligence algorithm finds a woman. The reason for this is not that this guy looks like a woman, is that most of the other factors made this more probably to be the picture of a woman. And this is because there was a bias in the original data set that was used for model training that had a lot more pictures of women in the kitchen than men in the kitchen. So of course, it's much easier to be falling into the trap of identifying the wrong agent, as in this case. Maybe not in this case. In this case, he said it was a man because, who knows, there was a bird. Probably that's easier. You don't have many women with a bird, but okay, of course, there's something wrong with the data set. And actually, it gets amplified by the deep learning model, the bias you have in the data set. So the model will have a bias that is stronger than the bias you had, the unbalance that you had, for example, in the training set. This is also something very tricky and that you need to be careful about, okay? And then, of course, all the generative models. We discussed a bit, this person does not exist, right? If I give you two pictures, it's not really easy to understand which is the right one. And so you can fake whatever, you can fake identity, you can fake accounts online, you can also make videos that are really not real. This is, for example, the fake on the right-hand side, and on the left, there is the real one. Imagine there is a video that is done on images of a person that says something that is very important, like, again, let's say Barack Obama. These are pictures of Barack Obama. Can you spot which one is the real Obama among these? In 3 seconds. 3, 2, 1. Well, you might be surprised to know that none of these is real Obama. So all these are deep fakes, okay? So this is really tricky because you need to identify this stuff. You know what can happen, and also it happened just as a joke, but you know what could happen in terms of social manipulation by credible people saying not credible things and basically triggering some social impact, okay? So I will not elaborate on that. You know more than me that the implication may be really, really unethical, okay? There are efforts in trying to find this. For example, Reality Defender, check this website, it's really nice. They try to use neural networks to fight against the bad use of neural network. So they detect synthetic stuff, synthetic media with AI inside, for example, application, pictures, videos, etc. So you have something, you are in doubt, and probably upload this and you get the answers. This would be a nice thing that everybody uses nowadays. At the same time, there are plugins for browsers that you can install. And if there is in the website some fake images that the artificial intelligence is telling you as such, then a disclaimer appears. So you can use your human judgment as of to believe or not believe what is in that site, because you cannot really rely that information to be true, since they tried also to make you fall into a trap by giving you some fake material, okay? So this is basically the kind of things you should be following attention to in terms of ethics and AI. And I hope this stimulates a bit your reflection and your interest on the topic, okay? So we are less than 10 minutes to the 5 p.m. threshold, so the final time of this time that we spent together. And the workshop, we can declare it all over right now, okay? So we went through some basic machine learning concepts and tools, also started with our labs. We did a quick lab on regression, another one on classification. We redid the classification lab with the a convolutional neural network after discussing a bit what neural networks are and their history. And then we had a small lab on an autoencoder and a small lab on a generative adversarial network. This is my choice for the day. I hope it was interesting for you. And just to stay connected, these are, of course, my contacts, the email, Skype if you need to reach me, and of course you can follow me on Twitter. I used to tweet mostly stuff related to AI and machine learning. By the way, it's not really a personal Twitter account, so it's quite related to the work activities and not much more. Okay, so I thank you very much for your presence and attention during this workshop, and of course many thanks to our hosts at ISGC 2021, to whom I wish, of course, a very successful week for this virtual conference. That's it. We are done. Enjoy your machine learning journey.
Yeah. Daniele, the final part is so wonderful. This is wonderful. It's perfect for a dinner speech.
Oh yes, that was intended to be one. It's not dinner for me yet, but it's it wasn't anymore for you. It's late night there. So
in midnight. Yeah, but I mean, thank you. It's wonderful. I mean, it's the whole day, and then you need some rest.
yeah, I will. Probably I will stop speaking for half an hour at least to recover some voice, because I have some teaching tomorrow, by the way. So we'll see.
Oh,
okay.
Thank you. It was really wonderful. I mean, okay. Thank you very much. Thank you.
Thanks
everyone.
to you.
Okay. Bye bye.
See you around. Bye bye. Good luck for everything, and enjoy ISGC. To those of you who are still following the conference this week in this virtual mode. Thanks. Goodbye, everyone.